So, hi everyone. It is pleasure to have you again at the podcast. So basically, we have Dmytro with us. He's a quant dev and he's a great person who is interested in a low latency C++ environment and more about quant development at HFTs. We have Himanshu with us. He's also a quant developer at an Indian HFT and has great experience in again designing and developing trading systems. And we have Shuvraneel with us, who is a third year student uh, BTech student at IIT Kharagpur, and he's currently a quant intern at an Indian startup, Quant Development. So this podcast is all about the quant developers. We'll be discussing everything and anything that quant developers do, how exactly you can be a quant developer, basically. So let me just tell you, Dmytro, Shuvraneel, Himanshu, let me just tell you what my understanding about quant developers is. So basically, as far as I know, quant developers are someone who build, design, develop, maintain the high frequency trading systems. They optimize the trading systems and all. Uh, Basically, optimize the performance of the trading system, where the orders are placed, quoted, and everything else. Do you have anything to add for viewers who can, basically that can simplify their understanding of what quant developers do? Dmytro, over to you.
Well, I mean, you're 100% right. The only thing, like, we often use high frequency word, but in each company, it has own meaning what high frequency is. So somebody would say high frequency is nanosecond resolution. Somebody would say high frequency is microsecond resolution. And for somebody, it would be like just second resolution who don't try to do market making, and they're just saying like we buy, sell with second resolution, high frequency, right? So every time when you speak about high frequency, you should really understand what type of business are you talking about. So for market making, it's nanoseconds. Usually it's your custom hardware, your collocate your physical machine into the basement of the exchange. You have very stable and consistent networking, and that's where your nanoseconds resolution comes from. Basically, very low distance, very small distance to the matching engine, custom hardware, including FPGA, ASICs. But if we are moving to more cloud oriented high frequency trading, then we should think about more microsecond resolution, since you cannot customize your physical machine in Azure, AWS, or wherever your matching engine is. Um, and in this context, there is like less hardware engineering role, because I mean, you cannot put your hardware. And in game, we put DevOps. So DevOps really crucial in cloud infrastructure. There is like a bit less software engineering, a bit more DevOps. And again, I know folks that just use JavaScript, to trade. I mean, it works for them; they make money. So who cares how long it takes to execute your order until your strategy is performing well? So you can there is like two ways to beat the market. You're super fast and you're doing market making, or you're super smart and you don't care what your latency is.
Right.
So again, depending on what context we are talking, the definition of quantum development might be a bit different. And we always need to understand like what we are targeting.
An interesting perspective, by the way. Yes. Himanshu?
Yeah, actually, very nicely, the Mitra have summarized what quant developer basically do. So, apart from that, Dimitro, would you like to suggest our young viewers who basically want to venture into quant development roles, what all things they need to prepare, or maybe what all things they should focus on, so that they don't face any difficulty if they want to go into quant development roles?
This is a great question. So I think there is no single approach to handle all cases, because each of us has unique background, unique motivation, and unique set of knowledge, right? So what I would really recommend is they're like pillows, like fundament of quant development. You should really be good with the tooling you are using. It doesn't really matter whether it's C++, it's C, it's Rust, whatever language you're using for your development, you should be really good, because during the development of the strategy or system, you will need to take a lot of decisions related how to organize, how do memory management, how do error handling, many things like this. And you should really understand pros and cons of each approach in your specific language. So definitely be good in your language. Know pros and cons of each approaches. Um, then you should be passionate about this. So you should really love what you're doing, because in trading there is a lot of stress. There is a myth that you will make a lot of money, but I mean, not everybody makes a lot of money, right? But definitely everybody gets a lot of stress. So you should really
Right, true. That's true.
love your work, because there is a chance you make money, but there is a chance you won't. But there is 100% guarantee that you'll be stressed. So you should enjoy what you're doing and love what you're doing. And
Oh,
once you are approaching like already preparation phase for the interview, I always encourage everyone. So go through operating system, go through networking, know your language, and just in case, I mean, some companies still ask it. Just I don't know, go through lead codes, solve some tasks, because there is always a chance somebody will ask you to revert a binary tree. You will
true.
never do it in your day-to-day work, but I mean, to get the job, sometimes you need to revert a binary tree, right, guys?
Definitely. So as you are mentioning about these things, so for example, low latency C++ is also important because, and then we were looking at the job description and then we
Yep,
selected some of the topics. For example, operating system, that memory management you mentioned,
yep.
network architecture is there, object oriented programming is there, performance optimization is there. So these type of topics, do we need to prepare before an interview test?
Um, it also depends what type of the interview. So usually interview is happening in like iteration. So you usually get like first you submit your CV, then you might get some home assignment or some online test. And during these stages, I mean, nobody will ask you to optimize, I don't know, network stack, right? Because
Right, right.
it's complicated question depending on the context. But if you're getting to the final stages of the interview, usually it's a loop interview with 3, 4, sometimes 5 1-hour interviews focusing on tech, non-tech domains. In this type of interviews, you might be asked like design the connectivity, for example. So what type of connection will you use? Why would you prefer UDP over TCP or TCP over UDP in this concrete case? What techniques would you use to improve the latency, right? So for this
Right.
type of interview, you need to understand basic concepts. If we are talking about juniors, so fresh graduate university
Right.
guys, you don't really need to know how to optimize, because this
True.
knowledge comes with experience. So there are like a lot of articles about it. Drop it. Focus on basic fundamentals, right? Understanding how WebSockets working, what is UDP, TCP, multicast, broadcast, things like this. Understanding why TCP takes longer than UDP, um, how to check network connectivity, like communication, how to inspect packages, basic things that potentially you might need on your day first when you join the company.
That's true. So, Shuvraneel, so what do you think about, like, what are you particularly using, and do you have any questions to Dmytro?
Uh, Recently, this might apply to all types of system development tasks, but I've been working on writing unit tests for a while now, recently. And I feel that having a very robust system to test your API calls and the trades that you're making on your system in a sandbox environment where the stakes are not high is really crucial to gaining a sense of security as to whether your system is actually working as intended and not throwing any unexpected side effects, since we are going to handle real money, right? So what are your uh, thoughts on how important unit testing is?
Um, yeah, I mean, it's hard to doubt the value of testing in general. Um, but again, we are talking about complex systems, right? And unit tests, they are designed to test on like class level, right? So basically, you take plenty of mocks, you put them into the class, then you call API of this class and expect that mocks will be triggered.
Right.
And this is like basic fundament of testing, but in many cases it is not enough. So my personal view on testing in general, that you should have healthy balance of unit tests. It's like first level of defense. So this is the first thing that you trigger when you complete development of the feature. This is the first thing you add once you think that your feature is completed, and this is something that you should always add to your pull requests, because if you just add the code without proof that this works as expected, I mean, there is not much to review, right? Um, but what I think that many companies, not many companies, but some companies, they underestimate the value also of higher level tests, like integration tests, performance tests. But again, the higher you get in this hierarchy of testing, the more complicated it is to run these tests. Because I mean, let's take as an example performance tests. How would you test performance, right? You need to do complete replay of the exchange. You need to make your CPU as busy as in production. So you need completely production environment and very reliable simulation environment. And this is another level of complexity. And whether or not you can run this test on each merge of your commit to the master, probably not, because it will take like a lot of time to set up, but it will also take a lot of power resources. You cannot, I don't know, build a data center to run your PR on a master when you have like, I don't know, 40 developers working on a project. So I truly believe you cannot write software without unit tests. So this is like undiscussable, right? It just doesn't matter like what technology you're using to run the unit test, whether it's Boost, whether it's C test, I know, doc test, anything you like. It's all fine. But again, we should really keep the healthy balance of this test. We shouldn't test like constructor destructor, right? You shouldn't like write unit tests and run coverage and make sure that you have like 100% of the coverage, because I mean, it should be reasonable coverage. But we should never forget about other tests. And as I said, like integration tests are crucial, performance tests are crucial, stress tests are crucial. But again, developing and running them is a bit more challenging.
Right. So let us now talk about the low latency part of low latency C++, because whenever we talk about quantitative system development, the term low latency C++ always, comes hand in hand. So from what I understand, the latency that we need to keep low or we need to minimize is you have an event occurring, you need to make decisions based on that event and place the trade on the exchange. So the latency between the event occurring and the trade getting placed on the system is our main focus. But as you said that for some market makers, right, it's the time scale is in nanoseconds. So how much does the the latency of a few nanoseconds really matter in real life trading systems?
Well, I mean, it really depends. It like based on your strategy that is using, difference of nanoseconds might make your strategy profitable or losing money. So as I said, there is no one single rule for all types of trading strategies. Your strategy might be like really. So we should think about trading from this perspective. You have trading strategy that takes input of I know some event and then generates the outcome, right? And you want to make it as fast as possible, but keeping your development costs at reasonable level. And then you should really understand your trading strategy. So what type of strategy are we talking about? Do we really need nanoseconds resolutions? Because addition, like multiplication, is already nanoseconds, right? So the strategy that does nothing has 0 nanosecond resolution, but you want to analyze it, right? And from this perspective, it's I mean it's hard to justify. It can be like doesn't really matter, right? I mean, couple nanoseconds less, more, who cares? I mean, our strategy is smart enough and not designed for this ultra low latency. Or if you are a liquidity provider and you need to, like, I know, cancel hundreds of events right now, like once you get the event, because you will expose risks and you will potentially lose money, then I mean nanoseconds will make a huge difference. So again, I think I will repeat it multiple times during the call today, but there is no single approach and there is no silver bullet that will work in every scenario, in every case. It really highly depends on what strategy are you running, what environment are you in. So, I mean, if you are not collocated in a data center with the exchange and where you can put your own server, nanoseconds already gone. I mean, your networking will kill nanoseconds. So, I mean, forget it. And at this point, like, who cares about 10 nanoseconds if you ping like 1 microsecond, right? So it really depends. In the system that I'm currently working, 10 nanoseconds is not a big deal. So, but I know folks that will say, yeah, that make difference.
Okay, so we were talking about low latency C++. Dmytro, I regularly come across your posts on LinkedIn or maybe reposts as well.
Yeah.
I truly admire the posts about the C++, low latency C++, and everything about quant dev in general that you share. So basically, these are the gold mines for someone who want to venture into quantitative development role or who is already into these roles and are interested to read more on it. So I would definitely request the viewers to go through your LinkedIn profile, not because it will add few followers to your handle, but because I truly think that it gives them a different perspective of about C++. So I think that you will have a view of maybe possible resources that they can refer for low latency C++. I understand that it is not required for someone who is a fresh undergraduate, but as the job market demands now, because I even see a second year or first year undergrad asking about how we can venture
Mhm.
into low latency. So do you have any resources in mind for someone who just want to enter like learn low latency systems?
So I think there is no single place that you would really get all type of information you need. But I
Okay,
can personally share like what I used to do and how I
sure,
approach
definitely.
unknown domains for me. So first of all, definitely keep an eye on conferences. So, for example, a lot of HFT companies, they present on CPPCon, on Meeting CPP. So recently there was a conference in Netherlands where folks from IMC also presented stuff. So keep an eye on all these conferences. I personally subscribe to all these channels on YouTube to make sure I get a notification once the talks are published, and take a look, because this will give you great insights about what is going on, what is happening, what topics are important for the companies, what
Right,
is the future of your tooling. So conferences are super important, I think. The second thing, keep an eye on what is your tooling, like what your language is currently working on. Make sure that you understand what is going on, what is the recent trends. Play with this, because many companies, like when you go to the company, you will be limited by internal standards. So, for example, the company
right,
might use only, I know, compiler version that doesn't support the latest standard. But at
right.
home, you can benefit from this. You can just pick any compiler you want. and take the latest feature that is just recently was announced. Make sure that you understand it. Why committee decided to bring this feature to the market in general? Because
Right.
I think this gives you a deeper understanding about the tooling. It gives you what was the pain in the past and then how they approach it. And I really think that you can benefit a lot from your side projects. So take something that is not super advanced. You don't need to build like nanosecond resolution, I know, system. Build
Right.
some simple component and try to measure it, right? So for example, let's take an example. I love this example, logging library. Try to build logging library. Measure the performance of your logging library. Write the infrastructure for this logging library. Make sure you understand how CI works, how to trigger the job. Write unit tests. Experiment with different frameworks for unit tests. Understand
Right.
what you enjoy the most. Write I don't know, performance tests. Think how you design performance tests. So the topic shouldn't be complicated and new for you, because otherwise you will spend a lot of time on understanding the how it should work. But I mean, most of us understand what logging does, right?
Right.
And we saw how it performs. Yeah, write your own logger. Try to think from this small project as a big project. Write CI for this. Write testing for this. Yeah, write documentation. Think how you can documentation keep up to date while you keep development. This is a huge challenge, right? We all know that
Right.
documentation is outdated quite fast, and you don't notice it until you need it. Um,
Definitely.
I think this is like crucial. And also don't spend too much time on lead code. From my personal experience, in recent years, I think since ChatGPT was hitting the market, lead code is getting less popular during the interview, but
Right.
people getting asked about understanding the language more, because lead code is quite unique experience. So great lead coder guy doesn't transform immediately to great developer, and vice versa.
So Dmytro, I have a question on that. For example,
Sure.
you mentioned about that like lead code obviously is a unique perspective of learning the language, because for example, let's talk about C++.
Yep.
If we do it on lead code, what we do is that we solve few questions that require the understanding of data structures and algorithm. While on the
Yes.
other side, you mentioned about understanding the language, right?
Yep.
So, how are these two things different? Maybe we should understand something more about the language that lead code doesn't require us to know. Can you just put a small light on it?
Well, I mean, for example, dynamic memory allocation. This is a huge topic for low latency applications. Once while you're writing the lead code task, what you think is like, okay, should I use stud map or stud unordered map, right? You
Right.
think from this perspective, like you think like what type of structure I will put so I can, I know, store
Solve
for
the
dynamic
problem.
programming, right?
Right.
But in low latency applications development, you also think what is the structure, but in many cases you also think like, does this structure causes dynamic memory allocation? Because the cost of dynamic memory allocation is big, right? I don't want to say
Right.
huge, but it can impact your latency. So and in lead code you don't think about this because it's not the core idea of lead code. Lead code is mostly like pick the right strategy, pick the right data structure, pick the right struct, what you want to store. Go ahead. Maybe think about algorithm, how you approach it. But
Right.
in day-to-day work, what you really like in my case, you think about what is the nature of the structure, whether or not it will cause dynamic memory allocation. Can I handle the same situation without dynamic memory allocation. Should I use if statement? How if statement will impact in branch prediction? How I keep the cache hot, right? Because false um, branch prediction will also kill your performance. And things like this, you will never think about it in lead code. So something like
Right.
unlikely, likely that is part of C++ standard, you will never see in lead code tasks, but you will definitely see them in your production code base for HFT.
True.
Yeah, things like this, they make huge impact.
True.
So
Himanshu,
basically,
yeah.
yeah. So
No, no.
basically, like Dmytro very nicely mentioned that it's like being a software developer is very different from being a good coder of algorithms. So it really
Yes.
was very helpful, and it will be very helpful for people who are like new to Quant. So also Dimitro, like apart from these software level optimizations, like which we were talking about, we know that hardware level optimizations are also necessary when we talk about low latency development or high performance computing. So like I was going through one lecture by
Hmm.
ETH Zurich. So it was a computer architecture lecture by
Yep.
owner Multu. So
Yes.
basically it was quite interesting. So there are many other resources also like that. We'll share them with the viewers afterwards. So would you like to also share some light on hardware level optimization which are necessary for low latency developer?
So when we speak about optimization, I prefer to see this optimization as a pie. So we already briefly covered that there is like software level optimization. So kind of like how you handle the the memory, threading, sharing resources. But then there is like two more layers that in many cases people don't think about them, but they make huge difference. So first of all, it's operational system level optimization. It's kind of like making sure your threads are not touched by some other applications. So basically, thread isolation, scheduler optimization, things like this. So there is like operation system level of the optimization. And then there is hardware level optimization. For hardware level optimization, we are mostly talking about things that you can configure on BIOS. So basically, power management, heat management, to make sure that you don't throttle your CPU, right? So that your CPU has enough juice to run all the computation. So for low latency, it's really you every corner of application you can reach, you must probably need to reach and adjust it. And in some cases, also, as we said before, you might want to put your FPGA or ASICs and benefit out of this. So there is like on every single step you can do something. As a software engineer, of course, I'm mostly working on not mostly, but I'm working on software level. I do not touch I know hardware or operating system optimization. But again, as a hobby project, no one is limited to nothing. So right, you can
True.
I know get some cheap PC. It can be like mini PC, and try to install Linux. Try to read articles about optimizations, how you isolate CPUs, how you disable interrupts, and things like this. Yeah, measure your performance. I think it's a great project.
Yeah,
That's an interesting perspective.
it
Yes,
was really
Himanshu.
nicely put by Dmytro. So basically, viewers properly got to know about the different types of optimization, the software, the system, and the hardware level optimization. And I feel that it's necessary in for a quant developer to squeeze out latency wherever possible.
But
That's
again,
true.
that's beauty and ugly side of company life, right? So if you're working in small company, then of course you are exposed to all these levels. But once you reaching some big company, you will be like really limited to one aspect on it, and sub aspect, I would say. So you won't touch like even all software stack, right? You'll be allocated to the team that is working on this concrete functionality. And I mean, understanding is nice, but again, I enjoy personally learning about all these levels, but it's not mandatory, because if you join big company, I mean, you want to work on all of this.
True. So basically, as you mentioned, for example, I observed that in Optava, basically, they have just they have a role separately for FPGA engineer, and FPGA
Yes.
was something that we had just studied as a single topic in our engineering days in electronics chapter. So everything is just when you go, everything becomes a full fledged role basically. So that's true.
Yeah, because
So
as I said, if you want to squeeze nanoseconds, you really need to know all corner cases and pitfalls, and this usually requires time and experience. So you cannot just say to CDev, "Hey, tomorrow you will be programming FPGA." I mean, this person would be able to pick it up, but the quality might be not the greatest one.
true. So I will basically I was going through job descriptions. So basically, we all were going through the job descriptions of different
Hmm.
companies. So
Sure.
the three things that are common in all those things are that C++ in a Linux environment, that Shuvraneel will come later on. But particularly, I wanted to ask a question related to multi-threading. Basically, the like how how useful it is and how can people prepare for it. For example, they wanted experience related to designing multi-threaded applications and development. Apart from that, one more aspect that I want you to stress on is that distributed system, what exactly it is, and basically like how what exactly distributed system is and how they can basically get a basic understanding of this.
So let's start with multi-threading and how important it is for quant dev. It is important. Period. The main motivation why it's important is that, as we briefly covered a couple seconds ago, that you need to understand this CPU isolation, so the CPU core isolation to run your application. How
Right.
application is designed that, let's say you have a physical machine with, I know, 24 cores, and you keep 4 cores for your operational system and 20 cores for your application. And then these 20 cores, they are not touched by anything except your application that is running on. That means that once you start the thread, you tell the thread on which CPU ID to run. And most cases, you have like dedicated threads matched to dedicated CPU IDs. And this relation is like one-to-one. There are some exceptions, but in most cases, it's one-to-one. And
Right.
that's how you guarantee that you don't have delay on scheduler level. That your task will be picked up immediately from the queue. And that's where the multi-threading comes into the game. You need to make sure that you can effectively communicate between different threads on inside your application. And that's why you need to understand like how to avoid uh, memory corruption.
Right.
So and then like what techniques are available for cross-thread communication? What what are pros and cons of each of them? So from this perspective, you need to understand. Why I'm saying understand, because implementation is quite challenging, and nobody will ask you during the interview, "Hey, write me, I know, log-free, wait-free queue." I mean,
Right.
forget about it. But once you join the company, you will see these queues everywhere, um, and you need to understand like what is the difference between, I know, log-free, wait-free. What is the difference between single producer, multiple producer, like when, what to use, what is the cost, how to work with atomic variables. Basically, atomic variables, this is most probably will be asked during the interview. So you should definitely know what is atomic, what is the memory order, which memory order when to use. This is very, very important. Yeah,
That is
Yeah,
very
Dmytro.
interesting perspective, by the way. Yeah, Himanshu.
Yeah.
and
So
just yeah, please go ahead.
yeah, please continue, Dmytro.
Just to sense about distributed systems. So as I said, there is like CPU isolation, and you run your application. But in some cases, you need to handle cross-server communication, right? And that's where distributed systems comes into the game, and make sure that whatever knows physical machine one is populated to physical machine two for any reason. It can be like multiple reasons, but let's drop this out of the scope. And that's where you need to understand how networking works, right? TCP, UDP, packet loss,
Right.
traffic, congestion of TCP, how to read the network, how to use TCP dump, how to use Wireshark, how to understand the network. Again, these questions most probably will not be asked during the interview because they are really context dependent. But understanding of this will benefit you in your first year of working in the company, because there is high chance that you will be assigned to the task. There is some packet loss. Can you take a look? What is going on? And yeah, then have fun.
Right.
Yeah, so very nicely put, explained about multi-threading and the various aspects of distributed system. So I feel that since we were discussing about multi-threading, it's nice that if we also continue our discussion on some lock-free data structures, as you also discussed that we have some lock-free queues we in the Boost libraries, or maybe some other lock-free data structures which ensure that there is we avoid some minimize contention, not using the typical mutexes, but we try to rely on atomic operations and to synchronize across multiple threads. So I think we can discuss, Dmytro, about some of the log free data structures which you feel users should know.
Um, yeah, I would really start with simple things. Try to implement single producer, single consumer, lock-free, wait-free queue. This is like based on the array, and try to do the same based on the node. Also, single producer, single consumer. Then try to implement spin lock. This is also quite important. And maybe stack. Also, think in context of single producer, single consumer. This basic concepts with single producer, single consumer gives you reasonably good understanding of atomic operations and how they work. Once you feel excited about this domain and you enjoy working with atomics and data structure, try to implement something more sophisticated. You can whether go into the direction of multiple producer or multiple consumer, or both multiple producer and multiple consumer. Try to implement, thread pool. Thread pool is very widely used in low latency applications, and they should be also thread safe. So think about what data structure you would use for the thread pool, how you pre-allocate the memory, things like this, how you allocate, how you deallocate. Start with fixed size thread pool. So thread pool that just allocate the same size of or length of memory and freeze it. And yeah, go from this direction. But again, your main motivation should be not the implemented lock-free queue. Your main motivation should be understanding the atomic operations and memory order and why they are and in general. I can highly recommend a great talk from CPP-Con. It's CPP-Con 2023. There was a talk, single producer, single consumer queue from scratch.
Okay.
And the author covers nicely how it's how to build it, like starting from not thread safe and ending in how to optimize it in a thread safe. So I think this is like must watch for everyone who is into multi-threading and C++.
That's great. So I would just like to repeat for the viewers that please refer to the CPP conference of 2023 where they discuss about implementing the LockFree data structures. So Randy.
Yep.
Thank you, Dmytro. That was really insightful about how we should approach to learn multi-threading. And I was looking at job listings of Dynamic Technologies Limited,
Mm-hmm.
and as you said that the lead code or code forces style metric that company use to filter out new grads is slowly decreasing, and I actually saw that uh, DTL focuses a lot more on memory management and IO operations.
Yep.
So for people like me who are in CS adjacent but non-CS majors,
Mm-hmm.
who are university students, so which courses apart from say the ones you already mentioned, like operating systems, networking, or computer architecture, uh, which courses such as are compilers important? So which courses should we take to make ourselves ready for this kind of scenario?
That's a good question because I also graduated not from CS, so I graduated from business informatics.
Okay.
So I'm more. I even like work as a counter for like 1 year, long time ago. So
Okay.
I have long journey. I can share it. uh,
Definitely, definitely.
so how I approach this? If you are not CS guy, and I know you're coming from mathematical background, physics, I know some this type of science, or if like me personally, like from business informatics, right? So more not like core IT, but more like something around IT, and you want to jump into this. That might sound harsh, but I think that maybe you should not start from HFT, but go in some other domain, because at HFT some folks are really crazy about your background. So in many cases, your CV will be rejected just because you don't have, I don't know, right education, especially for new grads, right? Imagine you get CV from a new grad that I don't know, Bachelor of Science in Physics, and then you have 10 CVs from Bachelor in Computer Science, right? I mean, the competition is crazy right now. Um,
Yes.
so I think people should think strategically over like I want to get into this domain. God knows why. God knows for what cause. Just want, and that's it. Think strategically, right? I see like in my day-to-day work that folks from gaming background, they are really good. um, Gaming is like I don't know why it's not covered that often, but gaming solves pretty much all the same issue that's trying to solve HFT. But I mean, due to the consideration of that in gaming people get less money. For one open HFT position, there are like thousands of applications. For gaming, I know way less, way less. But the knowledge that you will get in this domain is like priceless. Me personally, I'm coming from embedded world, and this is a lot due to the location. So I'm located in Germany. I mean, automotive world in Germany is crazy huge, plenty of good companies, a lot of opportunities. I mean, just use it. So if you're not and you're feeling that you want to think strategically, and maybe try to investigate other opportunities before you jump into the HFT. Maybe you won't even like HFT. Who knows? Because a lot of students, they are. It's also like in my company. I work with grads, and usually how it comes that new grad joins the team, and they are super enthusiastic and a lot of energy, good knowledge. But the problem is that our day-to-day work is not as exciting, right? Your day-to-day work, you don't write log-free queues because it's already written. There is some library in the code base, I know, written 10 years ago, done. You don't write scheduler, right? It's already there. You, I mean, most of the things are already there. What is your day-to-day task is extending the functionality, fixing
Yes.
bugs, and this is like way less exciting, to be honest, because that's why you need to understand, as I said, like you need to understand the core concepts of like networking, because some bugs are related to packet losses, like you need to check what packets you are sending, what you're receiving back. You will not write your own, I know, TCP server. I mean, it's already there. So that's why don't be hyped about technology, but be the master of your tooling. Because
Right.
once you are the master of the tooling, you can pick the domain you like. But if you like domain driven, there is high chance that you will learn very little in HFT.
True.
But you will might face a lot of different challenges. So it really depends. Also, I think like again, I said this. Try to do your hobby projects, because this is the best way to learn. With healthy combination of lead code. Don't be obsessed by lead code. Just know how to do it. And really think about some project that will excite you, that will make you work till 1 a.m. after 8 hours of work in the office.
True. True.
Something
That's
that
true.
you can really enjoy, and enjoy is like crucial in your work, because it's a long run. Um, Most people don't stay longer than 10 years in HFT. So if you're a fresh graduate, think about it, because if you join now, most probably in 10 years you'll be like, okay, I'm done with this. And think what you can learn from this. So that's it.
So, Shuvraneel, you're particularly mentioning about that you have a question. I hope you get your answer about how what type of courses people should go through in the hobby projects that they can do. Most importantly, learning the tools and technology is important, and not where not the HFT and all are important. So basically, these are two sides of the same coin. They should first know what excites them. And Dimitra, as you mentioned, on the offside, on non-professional level, it's quite true, because we are a fresh undergrads as well, and it's quite true that if there is something that you can do even after your regular 9 to 5 job, till 1 a.m. the night, this is the only thing that can go in the long run. Otherwise, it would be very difficult to survive that scenario. But interestingly, quantity finance is that thing for me, so it's working fine.
Yeah, that's
Sunil,
amazing. I also enjoy this a lot, and that's why for me it's great journey that I love.
right? So, because that is why I came across your LinkedIn profile, and I was amazed about your your into in basically C++ dev, SFTs and all. So basically, and that is why basically we invited you to the podcast. You really
Nice.
have a lot of zeal to share others, to know about new things, new technology and all. So yes.
As I said, I'm also not from CS, so I keep learning all the time, and I just love sharing. I think that one guy told me at the early stage of my career is quite interesting statement, and I really think that it reflects 100% to reality. Your seniority is defined by the speed you pick up new things.
Right.
So it's not about how much you know right now, but how much you can learn while you keep growing as a professional. So, and
Very
that's
true.
why learning is like skills to learn, like how you learn, how you approach new information, where you search for information. This is crucial for the engineering and development. So, and you should think strategically, right? Don't put the final stage like it's samurai, right? The samurai has the path, doesn't have destination. And in software engineering, it's the same. You have the path to learn, path to grow, and sharing is also quite important. And yeah,
So, thank you, Dmytro. That was really helpful as to how one should have an outlook as for a career progression and not directly jump to, the HFT craze. And coming to platforms, I saw that a lot of established firms in the space, like Optiva, have their code base in Linux, and they like ask for some experience in using Linux and comfortable. You have to be
yes,
comfortable in it. So, is there any like specific reason that Linux is chosen?
yes. It's free and customizable. I mean, that's it.
Okay.
Also, many companies are using Red Hat Enterprise Linux due to guarantee that Red Hat provides you and support. So if something breaks, they can jump into it and fix it, and at least they verified that setting of applications work correctly. And they provide also some instrument like documentation how to fine tune your Linux for different purpose. But for example, other companies are using Debian. And
Yes.
again, the reason behind it is that it's free, open source, so you can install your operating system on a server and just run it without any legal obligations. And you can also tweak it the way you can imagine. Any crazy idea that comes to your mind, you can potentially put it into the Linux, and you can extend it. You can write your own driver for your custom hardware. Do whatever you want. No limitations. Only your skills and engineers.
Okay, so that's very
But but
interesting
but
perspective. Yeah,
but
please.
Linux, yeah, just to final things. Linux will be definitely the environment that you will work in. There are some exceptions, like potentially you can, I know, have a Windows machine, but again, your application will be compiled and executed on a Linux machine. So there is no way to avoid it, and as the result, you will need to, since your production and testing environment is Linux, you will need to SSH into this server just for the purpose, I know, investigating logs, just to see what is going on there. And that's where a requirement for Linux comes from.
Right. So basically, as Shuvraneel was asking about the C, Optiver uses C++ in a Linux environment, and basically, as you mentioned, that Linux is an open source software, so they can directly install without any legal requirement. And the benefits of using Linux. I was going through the job description of HRT. So
Hmm.
basically, our plan was to go through the job descriptions and so basically reverse engineering kind of thing.
Yeah, yeah, yeah,
So basically, we were going through the job description of HRT, and
yeah.
so basically they mentioned that they need a person having a working experience of C or C++ and having
Hmm.
good CS fundamentals. Again, operating system, ops, network communication, kernel bypass. Himanshu will come back to those things, but particularly I was more interested in the term that they used, which was interest in the low level architecture basically. So what basically this term is, and how do they expect people to know about
Oh gosh, I have no idea what the term means. uh,
it. No issue.
because there is a lot of hype words in IT, especially recently, right? So when I was studying, there was just architecture,
Right,
and now
right,
there
right.
is high level architecture, low level architecture. God knows what level architecture. Um, I cannot answer this question, what they really mean, but what you really need to do is basically if I understand correctly. Again, I might be wrong, but
Yes.
high-level architecture is like you have server A, server B, you have database, you have, I don't know, some connections, etc. This is like high-level architecture. Avoiding and low-level architecture is basically you have socket, right? And
Right.
how you transfer the data from the socket to your, I don't know, order builder. So what data structures you will be looking for. So if you're talking about high level, it's like what applications you need, and low level, like how application internally should operate. Um, but again, I mean, this is new words for me. As I said, when I was graduating, it was just architecture. There was no high level, low level. Um but again, maybe for hardware engineer it will be something different. But for software engineer, nobody will ask you to go deeper than a couple data structures into your application.
That's true. That is why they probably mentioned the word interest only and not an experience. Yeah. So, Himanshu, so what do
Yeah.
you think about it, and particularly network and kernel bypass systems and all?
Yeah, so as Dmytro mentioned in the beginning also that network cards and NIC cards, these are very useful in the low latency systems when we are designing them. So specifically talking about the kernel bypass, so we should let our users know firstly about what exactly kernel bypass is. So just basic introduction I would like to give. So kernel bypass, as we know, is nothing but we try to skip the layer of the operating system so that we kind of minimize the latency of that particular part. And these are done using various cards available in the market. So and also there is a software approach basically called the DPDK, which is also used for this purpose. So if you could, Dimitro, just explain the basics of what exactly kernel bypass is, and also throw some light about the basics of DPDK. So it'll be very useful for our viewers.
Right. So kernel bypass. Uh, you need to think about the nature of the Linux kernel. The Linux kernel is designed to work correctly in all possible cases, right? So um, you will see Linux running on I don't know 20 years PCs. You will see Linux running on just recently announced PCs. You will see Linux running even on Macs, right? So Linux can run potentially pretty much everywhere, starting from small computers like Raspberry Pi, ending up NVIDIA supercomputers to train neural networks. So Linux is like very powerful, very diverse, very flexible tool. But when we are talking about HFT, you need to understand that HFT doesn't try to solve all problems, right? HFT tries to solve like one single problem: when to buy and how and when to sell, and that's it.
Right.
So and to solve this problem, we need information from the market, from some other information providers to make these decisions. And this information we need as soon as possible. The sooner the better. So, and that's where kernel comes into the game. So kernel doesn't care about our need that we need it as soon as possible. Kernel cares that any type of network interface card you plug into the PC will work and you will get your data. So kernel bypassing was implemented for making sure that all these corner cases that kernel handling for different type of hardware, for different type of scenarios are dropped. We don't care about this. We know what type of network interface card is in our system. We know where our application runs. We know what data we are receiving. We know this. We can guarantee this. We don't need all these checks and that the kernel provides, because nothing comes for free. All these checks, all copy data from one layer to another layer. It takes time, and what we want to make sure that we get data as soon as possible. So there are like multiple techniques how you can bypass the kernel. Bypassing, I mean making sure that your data goes from network interface card into your application directly. And you should distinguish hardware and software-only approaches. So let's start with hardware. They're like network interface card providers that give you special purpose hardware, like dedicated network interface cards with software that allow you to do this trick. So you just plug this physically in your server. You run this library, done. You have kernel bypassing with really nice interface. Everything is already optimized by engineers of this company. And the good example is NVIDIA, not NVIDIA, AMD. AMD SolarFlare. They are quite famous in HFT space. Very often you will see them in physical machines, and the library called Onload. These two guys playing together nicely and gives you best on the market latency. But in some cases, it's not possible to experiment with the hardware. And this, as an example, could be cryptocurrencies. So cryptocurrencies are currently 100% matched, like matching engine is located in the cloud. So AWS, Azure, whatever, Google Cloud. And you cannot just go to AWS and say like, hey, folks, I have here so awesome physical machine with amazing network interface card. Can you please plug into your data center? They will say like, sorry, we don't work like this. That's why you really need to rely on software only. So all participants of the market will get the same hardware, like physical machine from AWS, and it's up to you how you instrument the server. So what software you run on this, and that's where DPDK comes into the game. So DPDK is also a company that provides a collection of libraries that allows you to bypass the kernel. What it basically does, it just you have a chunk of memory that is mapped into kernel space and user space, and this DPDK is running on kernel space and reads the data from network interface queue and or buffer and puts it into the memory that is available into the user space, and you avoid all these checks and everything. You just take the data from the network and put it into the application level.
Basically, it's like a shortcut path we have created for the
Yes,
data to
yes.
directly come to us.
It's like think about public transport, right? So it's like I know, train compared to a bicycle, right?
Yes,
You have a bicycle that you can drive everywhere, uh, and but you always need to carry it with you, and it takes a lot of time. Or you have a train between like point A point B. You can just go between A and B, nowhere else, and only this time. But you go way faster. So it's like purpose dedicated approaches, and that's what I mentioned, that kernel should work like in all possible scenarios, but HFT, they don't solve all questions. We just need information, the sooner the better, and that's it.
exactly. Yeah, thank you, Dmytro. It was very well put, and I feel that users should be able to get a proper overview of what kernel bypass techniques mean.
um,
And
just to
yeah,
sense, if you want to experiment with kernel bypass, you don't even need DPDK. So recently there was technology called eBPF XDP.
eBPF, yes.
Extended Barclay package filter express data path. This is already part of the latest Linux, so it's not as good as DPDK at this point of time, but technology is very fresh. A lot of ongoing work is happening in this space. The good thing that it comes from with Linux, so you can already install Linux and play with this. There is also a great book called Learning eBPF that gives you step-by-step instructions how to do kernel bypassing with eBPF for TCP, but also for encrypted TCP. This is like an interesting point because you need not only bypass, but you also need encrypt decrypt packages.
Yes.
So I will just like to repeat it for you viewers. So basically, we were discussing on the kernel bypass techniques, and then we came to eBPF, and Dmytro shared a book that you can refer to learn about how to implement eBPF in native Linux tooling. So like probably we are much to attend, and we had a great discussion, to be honest, on everything. So if we are discussing about the kernel bypass techniques, and I was going through a LinkedIn poll basically,
Mhm.
where they had a poll on which kernel bypass technique delivers the best performance for HFT applications.
Yeah.
And so the options were Solarfare, Open on Load, basically DPDK, RDM, and Mellanox Smart NICs. So, what do you think about like which are the best? And Dmytro and
Yeah,
Himanshu, I guess.
actually, I saw this and I posted, and I think I even
Yeah.
left a
So
comment that currently Solarflare is like the standard. If you
right.
can access physical machine and plug into the server, then I mean that's obvious decision that you should go if you really into the low latency kernel bypassing. And if you just have I know operational software approach, then DPDK.
Okay. And Himanshu, you were probably mentioning some days to me. I remember that using Mellanox. Basically, do you have you? Can you just describe it for the viewers about what Mellanox Smart and
Yeah,
ICs are?
basically Mellanox cards are also like used for the same kernel bypass only. So basically it depends from company to company based on their resources and how their specific requirements. Basically they choose various cards. So some of the companies also prefer using these Mellanox cards because they have they provide a good trade-off between the performance and the cost which at which they come. So they are
Definitely.
relatively like, cheaper cards, but still their performance is quite good. So many, I've seen many companies use this Mellanox card also.
That's true. So basically, we had a thorough discussion on uh, kernel bypass, and probably, I guess, Sunil, you mentioning about Rust and all that some company being used that you have observed. Can you just describe about?
Not really. Recently, on the internet, I've seen that Rust is becoming much more popular as compared to C++ because of its speed as well as memory safety. So maybe companies which have lots of legacy code in C++ will be reluctant to directly translate everything to Rust. But Dmytro, would you say that Rust might be taking over C++ for, especially for new and coming companies?
Well, I mean, I see it already that companies that starting from scratch, they are picking Rust over C++, due to everybody known reason, right? It's not only safety from memory, but it's also overall like developer experience and the how fast you can write the software, right? So in Rust, it's kind of like you get faster to the point when it works. While in C++, you still need to debug all your bugs. But that's a good point that a lot of companies, they have a lot of legacy code, right? And if I would come to my manager and say like, hey man, there is Rust, it's so cool, let's rewrite everything from scratch in Rust, he will probably fire me. It won't be a long discussion. He will say I'm toxic and God knows what, not realistic, don't understand the business, and et cetera, et cetera. So I think that Rust will be like in a sweet spot for new project, definitely for a couple next years. At the same time, we see a lot of safety features in C++. So again, the problem of C++ safety is that the speed of C++, the nature of the speed of C++ is like row pointers, row access to the memory. And this is like why C++ is so fast, but at the same time, why C++ is not safe. And once you start adding the checks, you start putting everywhere if statements, right? If out of the boundary, if I know null, if it's something else. And this if statement, they create branches. And as a false branch prediction, you will drop the speed. So it's kind of hard will be to change the C++ into safe without speed degradation. But maybe a committee will manage it. I know committee is like a collection of brightest mind in the world. So I wouldn't say that they are not able for some tasks. I'm pretty much sure they can do any task, but it always comes with like, do they really care about this or not, and do they have enough resources for this, and whether compilers can implement this. So the C++ will get safer within the time, and I think that in next 5 years the benefit of Rust in safety will be pretty much not that important, that C++ is getting safer. At the same time, Rust still provides better developer experience, so and you can write software faster. So this will stay. I also think that if the current problem of Rust is that, I mean, you need to write the whole project from scratch. If you would be able to write, I know, just some static library from in Rust and then link into C++ project, that would be a game changer, because it's impossible to negotiate with the manager to rewrite the whole project, but it's pretty much possible to negotiate refactoring, right? Let's call it refactoring, but refactoring to rewrite it in Rust, because you can the whole project is split into I don't know 20 40 small static libraries with well-defined interface. You can pick up any library that brings you the pain the most, rewrite it in Rust within I don't know 1 month, and allocate like 4 engineers for this, and you are good to go. But as of now, integration of Rust libraries into C++ is kind of also not that nice. I saw there's some techniques, but I mean, it's too early to make it a production scale. So it's a hard decision. So as a fresh graduate, what should you do? Should you invest into C++, or you should go with Rust? I don't know. I think everybody should take this decision, take into account like what they prefer, what their motivation, taking all that is known at this point of time. I personally love C++, but I also understand if at some point of time Rust will dominate, I will just learn Rust and keep moving. So keep in mind that language is just a tool, right? The role of the software engineer is bringing business value, not writing the code. You don't solve memory corruption. You solve potential loss of
Definitely.
millions. That's your business value. Which tool you're using, it's not that important.
Right. That's true, Dmytro. So, am I audible, first of all? Sunil, Dmytro?
Yes, we can hear you. At least I can hear you.
Yes, Kshitij, you are audible.
Hello.
Yeah, Kshitij, you are
Seems like
audible.
yeah, we can hear you, but maybe you cannot hear us.
Okay. So, basically, okay, so there is a Wi-Fi down over here. Yeah, so basically, we are,
Seems like there is a huge delay.
yeah, now I can hear you. So basically, what I was talking about is that we had a lot of discussion today on everything related to quant developers. For example, low latency C++ is there. We have network architecture communication. We had memory management discussion on memory management. We have discussion on kernel bypass. Everything related to quant development. So Himanshu, could you just summarize our discussion for how they can prepare for quant dev roles, like what all did we discuss today and what all topics should they include in their preparation?
Sure, Kshitij. So I would just like to summarize So we had quite a comprehensive discussion on across various topics. So, firstly, for any new grad or any new developer who wants to come to this, low latency development field, he should be like pretty good in the tooling, whichever they are comfortable in. So, as Dimitro said, that instead of trying to master many things simultaneously, we should try and focus on one particular aspect in which we are comfortable and try to first master that, and later we can develop or maybe spread our our efficiency across multiple technology domains. But initially first try to make your basics strong, be it in your language in which you are working, say the C++. So firstly you should be very comfortable in C++, then go to the other concepts like the object oriented programming or the multi-threading part, the operating systems, and later you can also explore the networking part also, which will help you get a proper understanding of how things work. But as Dimitro said, that in the corporate world you don't get to work on all the technologies simultaneously, so you need to focus on one particular aspect and basically slowly kind of diversify your knowledge based on that. So the main thing which we should keep in mind is, uh, firstly, make your software development skills nice, and which shouldn't just be focused on algorithmic development, but also based on thinking how can we solve bugs, or maybe how can we develop some side projects, maybe write some libraries, or maybe experiment with different different projects which we can build ourselves, and which makes use of some low latency data structures, or maybe some log free data structures like the SPSC or MPSC queues, etc. So these things will give us an overview, it will give us an overall knowledge of how things work, and basically how we can tackle the real world challenges also. So if Subranil, if you would like to add something, you may.
So, one of the most important things as a university student that I learned from this was that, first of all, since I'm in a CS adjacent major, I should not directly jump to HFT jobs and maybe focus on exploring other potential options such as game development, as Dmytro mentioned, that they solve pretty much the same problems as HFTs. And also, it is really important to be adaptable and keep moving on. As you mentioned, that if in any case Rust takes over and becomes a major language, then you'd just be open to learning Rust and keep solving the business problems that the firm faces and not just writing code to push to production.
Yeah, so basically, as Sunil, basically, it is all about your understanding of the subject matter and what all are used in HFT. Is probably someone who is fresh graduate and want to enter into HFT, they can. So it's not a direct route as Dimitro mentioned, but
Yes,
anyway,
yes.
if it depends on personal preferences as well, right, Dimitro?
I just want to stress
And
out that all doors are open, and there is
right,
no
that's true.
predefined path for none of us, right? If you want to join HFT, this is amazing. If you want to join game dev, amazing. Embedded, all these domains, they are really great to be at. Um, just yeah, I mean, you can always later change the domain. It's not that you start in domain A and then you don't move to domain B. Um, it's just about your personal journey and your
Right.
personal growth as a professional, as a human being. Um, so yeah, just enjoy what you do. Make sure you keep learning and stay up to date to the market. And yeah, all doors are open. And the most important thing that you should believe in yourself, and you can handle anything. Like I can guarantee that anyone who is like watching or listening this, if you put the target within 6 months is, to get into Fang, I mean it's manageable. If you want to get into HFT in 6 months, it's manageable. It's only about your dedication and your journey. So uh, and your background, but you can do anything.
So, Dmytro, it was a great discussion to be honest, because particularly I am into quant risk, but I enjoy learning about everything about quantitative finance, whether it is quant trading, quant development, and all. And I get to learn a lot from you, from Himanshu, from what Shuvraneel is doing at his internship. So it was a great session. Thanks, Himanshu. Thanks, Shuvraneel, and thanks, Dmytro.
Thank you, guys.
Dmytro,
It was
as a final remark, would you want to suggest anything to viewers, basically any technical part, project part, and all? And then probably we would wrap up the session.
well. I mean, there is again, it's hard to suggest without understanding the context.
Right.
So, um, of course, based on each story, there might be different suggestions, but I think that it's very crucial in your career is like keep learning, enjoy what you're doing,
True.
respect yourself, respect your time, respect others, and I also enjoy the statement from again from my early days in C++. The code is written to be read and executed by accident. And the core idea is that whenever you write the code, make sure that it's understandable for other developers. And the understandability of code is way more important than its potential performance. So
Sure.
yeah, just do what you enjoy the most, and everything will be great.
So thanks again, Dmytro, and probably we can look forward to learn a lot from you in the future. Of course, keep sharing your insights on LinkedIn because we follow you and want to learn a lot from you.
Thank you.
Thanks again. Thanks again,
Thank you,
Himanshu.
guys. Have a nice day.
For the discussion. Have a nice day, Dmytro. Thanks, Shuvraneel.
Thank you. Thank you,
Thank you.
Dmytro. Thank
Cheers,
you all.
guys.
Thank you,
Bye.
Dmytro.